Rationalizing denominators. So in this video, I'm going to talk how to rationalize a denominator with monomial containing a square root, monomial meaning one term only, and a rationalized denominator that contains two terms. Okay, so although radicals follow the same rules that integers do, it is often difficult to figure out the value of an expression that contains radical. For example, if we have 1/2 or 0.75 or 6/9, we have pretty much an idea how much it is, right? But when we have, let's say, 1 over square root 2 or 1 over square root 5, do you have an idea how much it is? Of course, it's difficult because we can't imagine how much it's going to be. You can getting decimal notation and then you should divide the numerator by the decimal notation. So it's much harder to visualize and calculate in mind real quick. So, but and sometimes we have exactly what we need, work with expression, and when you do, let's say, calculations or project, engineers do project, they need some approximate value, just like, let's say, I'm trying to figure out how much money I need for something. I'm not putting the math and start adding or subtracting or any operation I just do rough calculation, and I calculate more at the rounding up generously, so I would know the maximum I will need that much money, for example. But when it's you get a square root 3 or square root 4.5, then you are lost, right? You can't figure out. And for projects, it's engineers who are doing project do math and they hit such numbers, it's going to get more complicated. So therefore, in the cases where we have fraction with a radical in the denominator, then we can use that technique that we are going to learn today, rationalizing denominator. Okay? And what is this technique about? It's about eliminating the radical in the denominator. Okay? So the point is to rationalize denominator that will help us to make it easier to understand what the quality really is by removing radical from the denominator. Okay, so what is rationalizing denominator itself? The idea of rationalizing a denominator, when it's coming from the word rationalize. So let's say if we have a number 5, for example, I can, or 1/2, or 0.75. So we all know that I can represent as a rational number, which is going to be 5 over 1 here, right? And 1/2 and 0.75 I can represent as a 3/4, correct, respectively. Some radicals are irrational numbers because they cannot be represented as a ratio of two integers. So as a result, it makes sense in such cases to rationalize denominator to change the expression so that denominator become a rational number. Okay? So the whole point of rationalizing denominator, convert irrational number to rational. All right? So, for example, if we have, let me clean this. If we have 1 over square root 2, this is irrational number because we have radical in denominator. But If I convert into rational, it's same thing. It's going to be square root 2 over 2. That's going to be rational. If I have 2 plus square root 3 over square root 3, irrational, let me write down here. Irrational, here is rational. Then the rational version of this, if we convert into rational, if we rationalize, rather saying, it's gonna be 2 square root 3 plus 3 over 3. And don't worry, I'm not just dumping their result, so I'm going to cover how we get there. Okay, said that, let's start. Let's take the simple case. We have we have 2 plus square root 3 over square root 3. Okay, so the denominator of this fraction is square root 3. To make it rational number, there is only one method to get rid of that radical. And to get rid of radical, we have only one choice. That is multiply by itself. Okay, so if we have square root 3, then I have to, because here is degree 2, I have to square it, right, to get 3 out. If I have cubic radical of 4, then based on this 3, I have to raise to power 3 to get 4 out. Shortly saying, if I have radical of degree n, then I have to raise to power n so I can get this 4 out. So let's work this out. 2 plus square root 3, 2 plus square root 3 over square root 3. So square root 3, it's a square root, right? Degree 2. Therefore, what am I going to do? Multiply by square root 3. And as we know, whatever change we do to the denominator, we are obligated to do the same change to numerator, right? And we are going to get here square root 3. I'm going just to do multiplication. Well, I guess I have to put here parentheses because I'm multiplying. So it's going to be 2 square root 3 and then plus square root 3 times square root 3. In denominator, I already have a square root 3 times square root 3, which means 3 will come out. So what do we have here? 2 square root 3 plus square root 3 by square root 3 is 3. And we have it. We have the result. We rationalized 2 plus square root 3 over square root 3. Next example. We have square root x plus square root of y and dividing by square root of x. Well, we have to put here condition x cannot be equal 0, right? Otherwise, fraction will not exist. So, since I have denominator square root of 6, then I have to multiply and divide by square root of 6, right? Square root of x plus square root of y. This fact that in denominator I have square root x, it enforced me to multiply in denominator and numerator by square root of x. And as a result, I put parentheses here, otherwise it will look like square root x plus square root y times square root x, so it's not entire parentheses. All right, so we are getting from here square root x times square root x plus square root x times square root y And here we get divided by x, right? So as a result, here we are getting x plus square root xy, because based on the properties of radicals, square root a times square root b is equal square root a b. Okay, so and we divide by x. Now here is crucial important thing I have mentioned in other videos, but let me mention here also. You do not dare ever pull out this x and cancel, because when any term tied up with addition, like here we have x is tied up with addition, then you cannot pull out, only if it would be multiplication. Okay, so and this is our final the result of rationalization. So I am working now with monomial in denominator. Monomial meaning only one term. Let's do another one, interesting case. We have square root of 100x over 11y. And obviously we have to put condition that y cannot be equal 0. So let me rewrite 100x over 11y. This is going to be equal square root of, I can separate them, 100x over square root of 11y, based on the property of radicals, that square root a over b is equal square root a divided by square root b. Okay, once we have it, now I have in denominator the square root 11y, which means what am I going to do? I need to multiply square root, oops, I used the thick one here. Multiply square root 11y in denominator, and same way multiply square root 11y in numerator. And as a result, we are going to get square root 100x in numerator. It's going to be 10, right? Square root of 100. Okay. See, based on this property, I can separate 100x, meaning, let me write down here. That means square root 100 times square root of x. Okay? Therefore, square root of 100 is going to be 10. And square root x, it's going to stay there, right? Times square root 11y. In denominator, I'm going to get 11y. So from here, what do we get? We are getting 10 square root 11xy divided by 11y. And that is going to be our answer. So we rationalized. All right, next we are going to do rationalizing denominator with two terms. Denominator do not always contain just one term. Sometimes they can have in the form of expressions, like this time I'll use blue one. It's let's say 3 over square root 2 plus 5. I told you already several times in previous videos also that when terms are tied up with addition, you can't pull them. You can't cancel one, leaving the other one without. Okay? Therefore, we have to work with this pair, square root 2 plus 5, for example. Okay? Is it possible to do that? And our goal is again to get rid of radical without bringing this 5 under radical. Yes, it is possible. So let me bring you an example, remind you the formula you all know by now. A squared minus b squared is equal a minus b times a plus b. Yes? Okay. So, or rather saying I should put vice versa, it will be much better for our case. I'll put it this way, a squared minus b squared right here. For example, if we have x plus 3 times x minus 3, I'm getting x squared minus 9, right? Based on formula. Okay? So if I have, let's say, square root 2 plus 3, then I have to multiply by square root 2 minus 3. Right? We are getting a squared is going to be square root 2 squared. And then minus b squared, which is going to be 3 squared. And the result is going to be 2 minus 9. And we are getting negative 7. This operation, let's say, okay, let me take example and we can start working. That's then I will explain. So we have, let's say, 5 minus square root 7. Divided by 3 plus square root 5. So in denominator we have 3 plus square root of 5. I took example and I don't know why I put parentheses, because it was there parentheses, and then I realized I don't need this parentheses. Okay, so 3 plus square root of 5. I can use this method, meaning multiplying 3 plus square root 5 by conjugate. So if conjugate meaning you multiply the same terms but with the opposite operation. Let me write down 5 minus square root of 7. Here I have 3 plus square root of 5. So conjugate will be if I multiply by 3 minus square root 5. Same terms, but I'm using opposite operation. And the same thing I'm writing down here. 3 minus square root 5. Let me put this also in parentheses. So it won't look like 5 minus square root 7 times 3 minus 5 square root 5. All right. So from here, what we are going to get? I'm going to start multiplying all this. And it's going to get 5 times 3. It's going to be 15. 5 times negative square root 5. It's going to be negative 5 square root 5. Okay. Next, negative 7 times 3. Negative square root 7 times 3. It's going to be negative 3 square root 7. Negative square root 7 times negative square root 5, it's going to be positive square root 35. Because square root a times square root b is equal square root ab. We have that somewhere. All right. Next, in denominator, I'm not going to multiply step by step because we are going to use formula a plus b minus a minus b, which means it's going to be a squared, which is 3 in our case, 3 squared, and then minus square root 5 squared, right? Which is going to be equal, so 15 minus 5 square root 5 minus 3 square root 7 plus square root 35 and divided by 9 minus square root 5 squared. What is it? Let me show you if you don't remember. it gives us square root 25, which is 5. Yeah? And we are getting here 4. Okay, let's do now pure math, math operation here. And we are going to get, actually I'm looking, there is nothing else to do there. So let me just write down the answer. 15 minus 5 over square root 5 minus 3 square root 7, and 35, I can't do anything. Even if I break down square root 5 square root 7, because I have here square root 5 square root 7, I can't combine because it's tied up with multiplication there. Because this is, let me show you, this is, I can break down square root 5 times square root 7. I can't do any like terms because it's they are tied up with multiplication. For like terms, I need only addition, subtraction. To cancel something or reduce, we need multiplication. Okay, so let me clean this. And I'm going to get plus square root 35 and divided by 4. Okay, another one, square the number 2. Solving number 2. Rationalizing the denominator, we have square root of x divided by square root x plus 2. So take a guess to rationalize. What do we have to do? That's right, we need to multiply and divide by square root x minus 2. Plus 2, and we are multiplying square root x minus 2. And as a result, we are going to get, so what is going to happen, square root x times square root x minus 2 times square root x, right? I just distributed the square root x multiplied by this and then by 2. And from here, we get in denominator square root x times 2 times square root x minus 2. It's going to be square root x squared and minus 2 squared, which is going to be in numerator square root x times square root x. It's x comes out. Minus 2 square root x, it stays the way it is. We can't do anything. Square root x squared, it's going to be x. And 2 squared, it's going to be 4. And we are done. Okay. One important note, rather saying a word of caution. This method will work only for cases when in denominator we have square root for binomials, meaning 2 terms. Okay? But it will not work if the roots are greater than 2. Let's say if I take, let me do some drafting here. If I have cubic radical of 10 plus 5, I cannot eliminate this cubic radical if I multiply by cubic radical 10 minus 5. It will still stays the cubic radical, right? So it will be, it's going to be 10 squared and minus 5 squared. The formula a squared minus b squared, correct? And it won't help anyhow. I still will have cubic radical of 100 and then minus 25. Because the cubic radical of 100 cannot be simplified further, therefore there is no cube numbers to pull out of cubic radicals, okay? And there is no conjugate that will help us to release the number from under radical. It works only with square root. If it's double, if you have binomial, in cases like this, binomial, meaning two terms. Obviously, if I would have, let's say, let me see, if I would have square root 2, or okay, square root 2 plus x, and here I would have square root, not square root, cubic radical of x only, monomial, but not binomial like here, okay? Then I can take care of it, and what I will do, I just multiply by the square. Let me see. Cubic radical of degree the raised to power 2. Why? I'll explain. So this square root 3, I mean not square root 3, radical of degree 3 of from x, it's, I can imagine, it's a 1, right? And here I have 2. So when I multiply, my exponents are going to add. So, and I'm getting cubic radical of x to power 3. 1 plus 2 is 3. If I would have, let's say, radical degree 4 only, then I would multiply radical degree 4. Here is x. So I need to have total 4, right, to get out x. So here I have already degree 1. Let me mark down. This is already 1. So I'm missing 3. Therefore, here I put power 3. I will multiply by 3 power. Okay? And this way I will get out let me see. I will take out only clean x, because cubic radical degree 4 to power 4 is equal x. Okay? That's an important note. All right, now I am really done, and thank you for watching, and I'll see you in next video.